Okay, so for years, we've kind of been told this one simple story. Natural gas is the cleaner fossil fuel, right? It's our stepping stone, our way of getting away from dirty old coal. But what if that's not really the whole picture? Yeah, the bridge fuel. You've heard it a million times. The whole idea is that we use gas as this temporary fix, this bridge to power everything while we get our act together and build out renewables like wind and solar. And honestly, on the surface, it sounds pretty reasonable. But what if that bridge is, well, a bridge to nowhere? Or even worse, what if when you actually look at the entire journey, that bridge is taking us somewhere even more dangerous for the climate? That's the huge provocative question at the center of some really startling new research. And this, right here, is where the story takes a massive turn. A major scientific analysis has looked at the complete picture of U.S. gas exports. And let's just say the findings are turning that whole bridge fuel idea completely on its head. No, you did not hear that wrong. According to a really comprehensive analysis from Cornell scientist Robert Howarth, when you look at the entire life cycle of liquefied natural gas, that's LNG, exported from the United States, its total climate footprint is actually worse, significantly worse than coal. So, how on earth is that possible? Well, the key is you can't just look at what comes out of the power plant smokestack. You have to analyze the entire messy journey of that gas, from the second it's pulled out of the ground to the moment it's finally used. It's a journey with a lot of hidden pollution. And this process is just incredibly complicated and energy intensive. First, you've got extraction, a lot of it through fracking. Then it gets piped to these gigantic facilities where it's supercooled into a liquid. That's the liquefaction part. From there, it's loaded onto special tankers and shipped across the ocean. And then finally, at its destination, it has to be warmed back up into a gas. Every single one of those steps uses a ton of energy and has its own emissions. This chart right here really tells the story of why this is such a massive deal right now. Just look at that red line. See how it just shoots straight up around 2005? That is the US shale gas boom. That explosion in production is what flipped the US from being a gas importer into the biggest LNG exporter in the world, creating this colossal global supply chain we're now dealing with. But to really get why LNG is worse than coal, we have to talk about the main ingredient of natural gas itself. We have to talk about methane. It's the hidden cost, the dirty secret of LNG. And there's a good reason they call it a climate superpollutant. So, what exactly is methane? Well, it's the natural in natural gas. And here's the catch. While it burns cleaner than coal and releases less CO2 at the power plant, when it leaks, when it escapes into the atmosphere unburned, it acts like a heat-trapping monster. Now, this chart is absolutely eye-opening. It breaks down LNG's total climate impact over a 20-year period, which is the time frame scientists say is most critical for getting a handle on climate change. And just look at this. The single biggest piece of the pie, 38%, comes from methane leaking out all along that supply chain. That is more, actually more, than the 34% that comes from the CO2 released when you finally burn the gas. The leaks themselves are a bigger climate problem than the end use of the fuel. It's wild. And here's why those leaks are so devastating. Over that crucial 20-year window, just one molecule of methane is 82.5 times more powerful at trapping heat in our atmosphere than a molecule of CO2. It doesn't stick around as long, but boy, does it do a lot of damage while it's here. Okay, so let's put all the pieces together. When the scientists crunch the numbers and account for the total greenhouse gas emissions for both fuels, well, a very clear loser emerges. So here's the bottom line. When you add up all of the warming impacts from the CO2 and that super potent methane, you get a total footprint, measured in what's called CO2 equivalent. And for US LNG, the Howard study found it clocks in at 160 grams per unit of energy. And coal? It's down at 120. That means LNG is at least a third worse for the climate than coal. And this bar chart just drives the point home visually. Look at LNG over there on the far left. On a full life cycle basis, its bar is the tallest. Taller means worse for the climate. It's worse than just using natural gas here at home, worse than diesel, and crucially, it's worse than coal. It's literally the worst of the bunch. Now, this isn't just some interesting fact for a science journal. This has huge real-world consequences. It's fueling a massive debate right now over the future of American energy policy and a proposed gigantic expansion of these LNG export terminals. In fact, you've got more than 170 scientists who are so concerned that they sent a letter directly to the White House, using this exact research as evidence. They're essentially saying, in no uncertain terms, that approving new LNG projects like the enormous CP2 terminal would be a massive step backward for the climate. And the scale of what we're talking about here is just staggering. According to that same letter, just this one proposed terminal, CP2, would have a climate impact over 20 times bigger than the controversial Willow oil project up in Alaska. 20 times. And the damage goes way beyond just the climate. The letter also points out something really important. These massive industrial facilities are often built right in the backyards of low-income communities and communities of color, especially along the Gulf Coast. They pump out toxic pollutants like benzene, creating serious health risks for the people who live right there. So, when you look at all of this, the science is becoming undeniable. When you account for the whole life cycle, and especially the knockout punch from methane leaks, that whole bridge fuel story just collapses. And it forces us to ask a really tough but really important question. If gas isn't the bridge to a clean future, what is? And how fast can we get building?